Hi, my name is Dr. Nalinda Somasiri. Today I'm going to do a coding exercise on machine learning on a specific data set, and we'll explain how we model a machine learning for this task. So in this task, we're going to use a diagnose2 CSV file, and that's the data set that we've been given. And what we're going to do, we're going to analyze the data set first and try to predict the diagnosis. And there are some feature data as well. So the first thing is we need to extract the data. Need to extract the data from the CSV file to our Python workspace. So once we extract our data set to the Python workspace, we can then do a bit of cleaning on the data. What does it mean by cleaning? We need to first do some sort of a pre-processing of the data. First, we need to identify the target and the feature data. So feature data is mainly the input to the machine learning model, and the target data is the what we are trying to predict, or it could be the output of the model. That's under the data cleaning. We're gonna go and identify the missing values. If there is any missing values, we're gonna populate that missing values with the mean values. That's the target. And we do a bit of pre-processing on the data as well. So once we do the cleaning process, the next stage is the feature scaling. So what does it mean by the feature scaling? We need to structure this data that we can feed it into the machine learning. So that's feature scaling. So once we identify our target data and then the feature data, we then do a bit of cleaning on the data cleansing. The process is called the data cleansing, and then we're going to do the feature scaling. Once we do the feature scaling, so we are going to identify the feature selection. So the features that we're going to use for our model and target, and then the target. So once you have the proper clean data set, right, so then the next task is to do the data splitting. So because we need training data to train the model and testing data for test the model. So once we identify the training and the test data, we're going to go through the KFold validation, which I'm going to talk to you in a minute. And then finally the ML model. So this is the process that we're going to follow on this example. The first thing is we need to extract the data to the Python environment, and then clean the data, identifying the missing values and populating with the mean values. Then we need to restructure the data that we can feed into the model. That is called the feature scaling and the feature selection. So what features that we're going to use to train our model, that is feature selection. Before we feed this data into the model, we need to split the data, purely larger portion of data for the training to train the model, and also a little portion of data to test the model, make sure the model behaves with a good accuracy. And finally the ML model. So this is the process, and also I'm going to talk about the KFold cross validation on the next slide. So imagine this is our data set, right? So before we feed into the model, machine learning model, we need to split the data for training and testing, as I explained earlier. So we do take larger portion of data to train the model and a smaller portion to test the model. But in KFold validation, what we're going to do, each iteration is not going to pick the same training data set and the test data set. So what it will do, each iteration that will pick up a different portion of test data. So in here, in the first iteration, you see this is the test data, and this portion would be the training data, right? On the iteration 2, what it does, so it just shifted to the right side. So now we are picking a test data which is not the same from the iteration 1. So it will be a completely different test data set from the previous iteration. Then this becomes the test data and the rest of the data becomes your training data. Again, iteration 3, you have seen it is shifted to the right side. Now we have a different test data, and this portion would be your training data. Again, we can do iteration up to k. So the basic thing is here we are not selecting the same test data and the training data in each iteration. So that's called the KFold cross validation, because that can capture the variance and everything, and then it gives you a better prediction for you rather than having a same test data and training data for each iteration. Okay, let's go and build this machine learning model. First we need to import the libraries, and then we need to extract the data. So we'll do that first. So I'm gonna create a Jupyter notebook file on here, and then we'll try to create this model. So I'm pretty sure you should be able to see the screen now. So let me make it bigger. Hopefully you should be able to see the screen. So first thing is first we need to import the libraries, right? So we're going to go and import the libraries here. So numpy is a numpy array package. So then we import matplotlib, splt, and then we're going to import pandas to create our data frame. So we could see the libraries are good. So I'm going to create more cells in here. So let me make it bigger. Right, now we need to read the data from the data set. So what I'm going to do, I'm going to get the data set, read CSV file from the diagnose2 CSV. So basically I'm extracting the diagnose2 CSV file to a dataset, pandas dataset, data frame, and we call the dataset is the dataset. Right, so we run that. So you would see using PD read CSV file, reading it from the diagnose2 CSV, we are extracting the CSV file to a data frame. So we can use some head command to check the dataset, right? At least the top few lines of the datasets. Sorry, it should be dataset, and then here we go. So now we got the few top rows on our dataset, so we can see what's in there. So it's sort of like a medical dataset that you will have medical parameters in here from x to the x1 to x13, and then the diagnosis, right? So there are 3 type of diagnosis, 0, 1 and 2, and also you have the gender on the second column, and then the ID, location too, right? So the Dublin, London, Belfast. So this is our data set. So what we're going to do, we're going to predict the diagnosis, right? That's what we're going to do, and we need to, that's our target, and then the rest from x1 to, and also we have a categorical data as well, not only the numerical data. We are planning to use them both the numerical and the categorical data for our modeling, but we have not yet identified this. But first of all, we need to identify the data set. We've seen it. We've seen first few rows, and we have identify what the targets are. But then again, we need to see how much the size of this data sets, right? So we can use len command to identify the size of this data set. So it's around 392 rows. So that's the size of it. And we have, and also we can find out the column sizes as well, how many columns are there. So we can use dataset column size, so that will give you the number of columns, so from here to there. So that means we have 17 columns in here, right? The size of the data is 392. And then we need to identify x. So what we're going to do for the x values, like an input to the system, and then the target values, right? So we're going to call the feature data x, right? So the data set ilog, this is all rows from column 3 to 16, and we're going to take the values of that. So we assign that to x variable. So that's our x variable feature data set, and then we're going to do the target data, right? So the target value would be the final one, which is the diagnosis, right? So we're going to call y dataset ilog all rows 16, which is the diagnosis. So we know the target data and we know the feature dataset now, and we are taking the value of it. So since we are taking the value, we can check the type, right? So we can type x. So that would give you the type of the x. So you see it's a numpy nd array. So that's what x and y are. The next thing is, we're gonna take values for new variable for the categorical data that we have. So we can easily use so all 1 to 3 here. You see 1 to 3 are categorical. 1 to 3 are categorical, gender and the location, and then the all rows. So new variable for the categorical, so we can use that d. We can assign that to d, right? So that's our categorical variable. So now we can visualize and see what the d looks like. Well, dataset, we can go and check the dataset now. Dataset head, we can use 5 to locate the first 5 rows, right? You see in it here. So as you could see, there are not a number values, none values as well. So the next step would be to get rid of that, right? So we do need to get rid of these missing values. So before that, we're going to check out what x looks like, because we converted into a numpy array. If I type that, you see that's in the form of the values, right? The numpy values. And also we can check the y values too. So the y values would be your target values, which are 0, 1 and 2. So you see the target values will be in the 0, 1 and 2, right? So that's the diagnosis that we're going to predict. And we can check out the d. We already created a d value from 1 to 3, right? We can check that d. We can do print command to do that, print d, and see what d looks like. So d is basically because we are selecting columns 1 to 3, which is gender and location. So you see the gender and location of the d, right? And we have taken that categorical values in here. So all good in here. So now we are studying our data set, and we can use the describe function to identify the summary of the data set. So we can use display dataset describe function to get the summary of this data set. So basically we will get the count of the data set 392, and the mean, right? The mean of x1 to x13, and also the diagnosis, right? So all good in here, and then there's a standard deviation, mean values, and the first quartile range, and the second and third, and the maximum and the mean values too. So we have a idea of the data set right now. So the next step is to do the missing values. So that's the second step that we're gonna do, which is the identifying the missing values. So basically we need to get rid of the non-values and then populate with the mean values. So we can use this code from scalar import simple imputer missing values npn. And strategy is we're gonna replace all the np non values with the mean values, and here we are specifying from 0 to 13 column and imputer fit transform and x with this. So that means any non values will be populated with the mean value, right? So we can see that. So before that, if I go scroll up a bit, and you see there are non values in here, right? So let's here index 5 third row, and you see the non values. So let's see, it will populate with the mean value. So we're gonna print x right now and see what we're gonna get, right? Here we go. And again, these are values that we taken, so that is populated with the values now, numpy values. The second step is to get rid of the non-values for the categorical features, right, which is D in our case, and we're going to use this imputer if I create more rows in here. Imputer, simple imputer, missing values, np imputer missing values, np non-values. So here we have the imputer fit transformation. So we're gonna print out the second print out the d values in here, right?